Now let's see code conversion programs. So there are different types of code like binary code, hexadecimal code, BCD or decimal, ASCII, etc. So we have to write programs to convert between them. So first let us take binary. So you know that binary 8 bits are coded as a hex number 1 byte to BCD. So BCD or decimal. Let us take an example. You know that last 1 byte number is FF in hexadecimal. Its decimal equivalent is 255. So remember an important thing. If you are having a 1 byte hexadecimal number, if you convert it to decimal, we may have 3 digits, 255, 3 digits. So one space is not enough to store the result, because in memory 1 byte can be stored. That means 2 digits. So these 2 digits form 1 byte called lower byte. So it occupies one space, and this 2 you have to save it as 02, because you cannot save as 2, because in memory always a number is saved as a byte. So 55, 2 digits form a byte, is lower byte, and 02, actually 2 is enough, but we have to store it as 02, that forms higher byte. So if you have one hexadecimal number, if you convert to decimal, you have to store 2 things. One is higher byte, another is lower byte. That's the point you have to remember. So one hexadecimal, if you convert to decimal, you need 2 space to store, because in in memory only in one space 1 byte can be, 2 digit can be stored, not more than that. Now the question is, how will you get this FF to 255? You take normal mathematical basics. You know that when you have a number 255, this is called hundreds place, and this is called tens place, and this is called units or ones place. This is what the meaning is. Now why it is called hundreds place? Because hundreds place is obtained after division by, obtained as a quotient after division by 100. How will you get tens place? After dividing by 100 you have a remainder, divide it by 10, so that is tens place, and units place means the remaining. So how will you get this 255 is divide by 100, divide by 10 and remaining. But in hex you have to divide by not 100, hex equivalent of 100. So your number, hexadecimal number, to get hundreds place, you have to divide by, since it is hexadecimal number, you have to divide by hexadecimal equivalent of 100. Hexadecimal equivalent of 100 is 64. Why? 6 hexadecimal base is 16. 6 into 16 is 96, plus 4 is 100. So divide by hexadecimal equivalent of 100. Remember, hexadecimal equivalent of 100 is 64h. So you got quotient, no? That is hundreds place. You can directly save or store as higher byte of the result. Now you got the remainder, that is combination of tens place and units place. That is combination of tens place and units place. Now you have to separate. How will you separate tens place? Divide by hex equivalent of 10. That is nothing but 0h. Divide by 0h. You got quotient in A, that is tens place, and the remainder is units place. So this is tens place, this is units place or ones place. Now when you have 255, hundreds place has to be separately stored, but tens and units place, one number, you don't have to separately store in 2 places. You can combine, or you can pack them. You can pack them and store in same place. So I have to pack tens place and units place. How will you pack? 2 numbers, one in tens place, another is in units place. Tens place has to be swapped and then added with this, so that you can combine or pack tens place and units place. That can be saved. So this is what the algorithm is. Let us try. So take a question. We have a hex number in internal RAM location 30H. We have to convert it to decimal number. Convert to decimal and store higher byte. Higher byte means hundreds place in 31H and lower byte in 32H. Lower byte is formed by packing tens place and units place. You have to pack and store. So let us take the program. Let us know it is mentioned that your number is in 30H. That you take it to A because we have to divide by 64H first. So number is taken to A. Now to divide operation is div AB. That means B should contains the second number. So a second number is constant 64H. No, divide by hex equivalent of 100. That is 64H. So move B comma. Since it is a constant data, I will write hash. Hundreds hex equivalent is 64H. So you can divide by A and A divided by B. That operation is div AB. So you got quotient as hundreds place. Hundreds place is the higher byte. You can store directly the higher byte in, I mean quotient or higher byte or hundreds place in A to 31H. So this is done. Now your remainder is in B. You have to separate it into, you have to divide by hex equivalent of 10. Then quotient will be tens place and remainder will be units place, and then you have to pack all those steps required. So my remainder is in B. I will take it to A. So now remainder has come to A. You have to divide by hex equivalent of 10. That means 0AH. So for division, B should contain that constant data means hash 0AH. So you can divide div AB. So after division by hex equivalent of 10, your quotient will be that in A, that will be tens place, and your remainder that is in B, that is units place. You have to pack them. How will you pack them? How will you pack them? Tens place is in A. Tens place is in A. Tens place in already in A. So for packing tens place, swapping has to be done. So swap A. So tens place swapped, and units place is in B. So since after swapping your second digit is 0, I can do or add. Both can be done. So remember, tens place is in A, that is swapped. With that, I will add or ORL A with units place. Units place is in B. So save that, answer will be in A or result will be in A. Save it to next location 32H. So this is how you have to convert hexadecimal to decimal. Once again I will discuss. Take the number to A. Divide by hex equivalent of 164. So quotient will be hundreds place. It is a higher by after division. Divide it. After division, your accumulator contains quotient which is hundreds place, which is higher byte. Store it. Now remainder will be combination of tens place and unit place. Take it to A. divided by 0a, that means hex equivalent of 10. So tens place is in A and units place in B after division. So tens place in A, units place in B. We have to pack this number. How will you pack the number? Tens place you have to swap and add with the units place. Units place means B. Instead of add, you can do ORL also. If unpacked number, if you are packing, you can use that. Then store it in one location. Now let us see the reverse. I mean decimal or BCD to binary or hex. So let us take an example. 1 is a decimal. You know that 10 in decimal is equivalent to 0a. 1 in decimal is equal to 0b in hex. How will you get this? Separate this number into tens place and units place. So tens place multiply with 0a. Units place you don't have to do anything. Just add. Here add only. No or operation. 0a plus 1 is 0b. This is how you have to get. So first you have to unpack. How will you unpack? 1 you do with F0. So you get 1 and F is always a number with F, and with F is that number itself. 1 and 0, adding with 0 gives 0. So you got 1 0. So it is a tens place. So you have to swap to make it 0 1. You have to swap it to make 0 1. Then multiply with 0a, add with the units place. This is what it is to be done. So let us say, and remember, 1 decimal will have 1 hex, unlike the previous question. So 1 decimal will have only 1 hex. So let us take an example. Your decimal number is in 30h. Convert it to hex. And store in 31h. This is the question. So what you have to do? Take the number to A. So number is in 30h. Take it to A. Okay. Now you have to unpack into tens digit and units digit, so that you can multiply tens digit with 0a and add it units digit. So you have to unpack. How will you unpack? ANL A comma hash F0H. Since F is the first number, write 0 before, prefix it. Just to representation. If you don't write also, no problem. F0 also you can write. So it has done F0. So tens place has been separated, and make it unpacked number. That means first number should be 0. So you have to swap A. This tens digit has to be multiplied with the 0a. So to multiply, B operator is required with the constant operator 0ah. Then multiply between these swapped. That means swapped means unpacked tens digit. So multiply that with the 0a because it is a tens place. So your result is in A, and remember this B will always be 0 because you know first number here is 0 and here also first number is 0. So obviously it will be a 2-digit number. So answer, you know, that tens place multiplied with the hex equivalent of 10 is in A now. Okay, is in A now. Now we have to add with units place. So you have to separate into units place from the number. We have not done that. So you have to separate into units place from the number. So one option is free this A by moving it to R0. Then take the number once again to A and ANL A comma 0F. Then add between A and R0. This is one method. I can avoid this. Why? You know, because ANL operation allows left side memory to be written. It allows. I can write with ANL left side not only A, I can write a memory address also. So I will make use of that. So you know that your number, actual number is to be taken now. Actual number is in 30. With that I have to do ANDing with the 0F to get the units place. And after doing that I can store there itself. So what I am doing is ANL, instead of writing A, I will write memory space where the number is present, 30H. With that I will do ANDing with the 0F and separate units place and save in that 30 itself. That what I have done, ANL 30H comma has 0FH means what? The number is ANDed with the 0F. When you ANDed with 0F means we got unpacked units digit. That is saved in 30 itself. I hope you understood. So what I have done, I have taken the number because number is in 30H. That is ANDed with 0F. That means number is ANDed with 0F means I got units place, unpacked units place. That units place is stored in 30 itself. Now units place in 30 and multiplied product in A. So I can do add A comma 30H. I hope you understood. What I have done this step, I have taken the number because number is in 30H and ANDed with the 0F. ANDed with the 0F means it becomes unpacked units digit. Units digit has come. For example, it is 49 and with the 0F will make it a 09. That is nothing but a units place. So what I have done, units place, that is after doing AND, it is stored in 30 itself. That means number is changed because we don't want number further. So number is taken, ANDed with 0F means units place, it becomes, that number becomes ANDed with the 0F means it becomes, result will be units place. That units place is saved in 30H itself. So unit place in 30 and multiplied result in A. So A and content of 30 which is units place we add. So your result will be in A, that has to be saved to the next place. I mean from A it is told that you have to store the result in 31H. One point you have to remember, here you have to use add only, not OR, because with the product we are adding, not with the unpacked number we are adding. So you have to listen this point once again. You remember what I am taking the number itself, ANDing with the 0F. When you AND with 0F, units place will be, number will be converted to its unit place. That unit place is saved in 30 itself because in left side I am writing 30. So unit place will be in 30. That will be added with the multiplied result in A. So result will be in A, store it to 31H. This is what it is done.